Hello friends, welcome back for a new video. So today we are going to see one more manuscript from a reputed journal. So the journal is IEEE Transactions on Pattern Analysis and Machine Intelligence. So this journal is one of the reputed journal in terms of its impact factor. What it is having, you can see it here. So IEEE transactions and pattern analysis and machine intelligence. Of course, this journal is the topmost journal in uh, IEEE transactions with a huge impact factor of 17.861. And we are trying to choose an article from this journal so that we can have a really a quality one for our analysis. And of course, we are going for the current issue of this journal. In this current issue, a good number of articles are there, and we are choosing one of the article. We can just go through this here. So this is the latest current issue of this journal, and from this journal, yeah, we are choosing this article: Novelty Detection and Online Learning for Chunk Data Streams. So, what is the meaning of novelty detection? Novelty is nothing but a newness. What is the new? What is the different one? So that one is called as novelty. So here, in this article, the others are trying to tell that they are going to have the novelty detection, finding new classes for classification on online learning process for chunk data streams. Okay, so as this paper is goes on like this here they have published some three proposals, three new algorithms which can work excellently on these online data streams here. Okay, so just go through the paper which I have downloaded for you. Yeah, this is the paper. I got the newly revised version. Okay, so novelty detection. What is meant by novelty? I said just now that it's finding the new classes, finding the new classes in online learning. So online learning is nothing but where we are having the data streams which are coming continuously, and we need to find out the classes or we need to do the classification. And in this, the doing classification is the only thing what normal algorithms are trying to do. But the others claim that here they are not only trying to do the classification of the existing classes. Meanwhile, they are trying to find the new classes which can be there in the data. So that is what they have laid stress here. So you can see here we can go for the abstract. So this is the abstract. Data stream analysis is the target of this paper here, where they are going to do the analysis of the data streams by having a online learning process here. So this paper proposes an efficient framework for novelty detection and incremental learning. So as the data streams are coming here, chunks of data are coming here, the learning process should be an incremental learning process, which should be updating the model continuously. Okay, so they have given a point that accurate factorization free kernel discriminate analysis. This is the concept by which they are trying to learn the new features. They are trying to learn the new features, and thereby by using those features, so they are trying to find a another factor called as reproducing kernel Hilbert space, RKHS. So by using this RKHS, they are going to find the unlabeled chunk data, and they are going to detect the novel classes in the decision model. So they have proposed three models by using this basic concept, they have first proposed FKDAX, that is nothing but factorization free kernel discriminant analysis. X is the first one, and on basing on that, two optimal new methods has been produced known as FKDACX, which uses micro centers for doing more better classification, and another one FKDAC, which uses the centers, for finding the class centers of the original data as the input for extremely fast speed online learning. Okay, so that was the main three proposals, and of course they have did the experimental validation on a good number of data sets here. So you can see here, they applied on real world data sets here which are of large scale. On that they have applied this algorithm, and they are claiming that they got good results from this algorithm, which has very low computational class, and good accuracies has been produced when compared with the state of art algorithms, right? And then going for the main concept of this paper here, so what they are proposing here, so here you can see they have summarized the concepts of this paper. From the perspective of online learning, they are giving three limitations for the data chunks online data stream learning. First is that new concepts can be incorporated into the existing model chunk by chunk. However, the previous several models are not considering any nullity pattern appearing at that time. They are just trying to postpone it to the later session, that at the end they may try to do it here, but that's not possible. That is the first limitation. And second limitation is the model should provide an efficient way to target and delete outdated concepts. So that concept also they are incrementing, they are implementing in their new models. And the third one is the model should maintain just a small amount of information. Of course, because it's an online learning, the things are coming fastly, so you don't have much memory to maintain. So you need to maintain a small amount of information for remembering previous data. That's the third one. And fourth one, the learning model can tackle the unbalanced sampling problem, which is a peculiar in the continuous learning system. Of course, this unbalanced learning problem is one of the greatest and growing research area where we are having the real-time applicability. When you are taking a data set in real time, you are not going to get a balanced data set. Of course it will be an unbalanced, where we are having one class with more number of instances in percentage point of view, and other class will definitely have the less number of instances. So in synthetic instances, you may have a balanced data set, like a data set is there which is having 100 instance, then in that 50 will be one class, 50 will be other class. That is possible. But in the case of a real world data set, you will not have a perfect balanced data set. You may take anything, okay, it will be definitely an unbalanced data set. So this research is going to solve that problem also. Okay, let us go some more into this one. Then here, what they have given here, what are the feature sections what they are presenting here. In section 2, they want to provide the main kernel novelty detection using DAs, that is discriminant analysis. And section 4 presents the concept of factorization free kernel discriminative analysis. And section 6 describes the incremental version of their new proposals, and 7th gives results, and 8th summarizes the conclusion. And and the related work is presented in number 2. And going for mathematical background, so they have just defined what is meant by a factorization free kernel DA method. And here they have talked about some more thing called as a problem of small sample problem also. When we are having a small sample problem, how our algorithm is going to make the classification. Of course, when we are going for online learning, you are having a small samples only. when that small samples are there, from that small chunk of samples also the model should be able to do proper classification. And whereas when incrementing process is going on, when new chunks are arriving, the model can have more instances, but at the initial stage it will have very less number of instances. So a small sample problem is also addressed by this research what they are telling here. Then the models what they have proposed is this one, first one, FKDAX is the first model what they have proposed, and the second model is FKDA C is what we can take second model, and third model what they have proposed is FKDACX. This is the third model what they are preparing. Okay, so right. So then going for the complexity, they not only have proposed the algorithms, they have given the complexities also. So these three last one, FKDAX, FKDACX, and FKDAC, these three are the new proposals. How they are working on the case of here time complexity and space complexity. They are claiming that their algorithms perform better on both the concepts of time complexity and space complexity. Okay, so then going forward, yeah. So complexity comparison is also discussed here, and novelty detection is done by using this algorithm, algorithm number 4, which is having the view regarding the novelty detection and classification. So the first three are the main concepts here, and then by using that concepts, what are the three one here? Once again, recalling here, FKDAX is the first proposal, FKDACX, and FKDAC. So FKDAX uses factorization-free kernel discriminative analysis, and FKDACX. So here you can see the three pictures which can give you a lot of clarity. So if you just zoom up here, and you can see a good clarity can be obtained by using these three diagrams here. So here, so this one, first one is the space learned by FKDAX. This is FKDAX. So here there are three classes. So those three classes has been finded out, classified by using this factorization free kernel discriminative analysis, FKDA. And then B is space land by FKDACX. In B, what they said, in CX they said that they are going to use micro clusters. That means when we are having one class, in that class they try to find one more small class, and they are trying to combine those small classes to form a big class. So this is in intra classification clusterization. So here a class is identified, in that class small clusters are identified, and these clusters are combined to form one big class, that is micro cluster technique they are using. And last one is C, the space land by C. So there, here they are finding first a class, and the class center they are taking out. By using this center they are trying to find the novelty of the new classes, are the instances coming in this class. So these are the three main concepts you should understand about these three algorithms. FKDAX uses the novelty concept of factorization free kernel discriminative analysis, and this uses the second model uses the microclusters. CX means microclusters. Here C uses the centroids point here. They are going to use the centroids for this. Okay, so then going for forward here, so now they are again using the online updating scheme. And as this is an incremental learning algorithm here, so they are not only going for finding the proper classification, novelty class identification, but also they are trying to do the incremental learning. So that incremental learning they are trying to do it here by using this here. Okay, so incremental learning is done by using this another algorithm, algorithm number 5. So here we are having this yes, so incremental FKDACX, they have again finded out three more versions of IFKDA1 version, And see here, this one, sixth one is IFKDA X is one version, incremental version of FKDA X, and then second version, uh, IFKDAC. It is incremental version of the center concentrated model, and third one is IFKDACX, incremental version of factorization free kernel discriminatory analysis for CX. CX is microclusters, and again they have finded the complexity of these three new proposed algorithms, that is improved versions, incremental versions of this one: IFKDAX, IFKDAC, IFKDACX. So for all these three, now for comparative purpose, they have used this incremental versions of the algorithms: ILDA triple S QS. This is the small sample problem what we say triple S here. So that algorithm also they are using for comparison. In reference number 35 you can get it here. In reference number 11 you can get the version details regarding this one. Okay, and then they try to go for the experimental analysis. So in the experimental analysis, these are the data sets what they are taking: ORL, AVAWA, and CATEC 256. These are the four data sets they are taking. And of course, they have said this, these data sets are publicly available. These data sets are publicly available. Four publicly available data sets are used. That means now it's your part to go and find these data sets. As they said, it's publicly available. Then why can't we go and download the data sets? They at least get this simple thing from the manuscript, getting the data sets. Okay, so it's publicly available. Go to this reference number 36, 37, 38, 39. There they are publicly available, so get it from there, download the data sets first thing. And then going for, again, not only the data sets, they had given their FKDA, that is nothing but factorization free kernel discriminatory analysis new model. Source code is also provided. They had given the place where that source code is publicly available. Of course, you can go and get that source code also. See, this is the batch learning. Now, in experimental process, they have made three type of learnings here. You can see it here. Now, see, so how they are going to have the configurations of the system. So this is the most abstract way of presenting their experimental setup here, just telling that they have used a MATLAB and they had used Intel Core i7 processor, 3.40 gigahertz PC with 8 GB RAM. Okay, so this is the code. So the code is proposed algorithms are available at in the GitHub. So just go and get that one. Click that link, go there and download this FKDA, factorization free kernel discriminatory analysis. Then you are having the algorithm, you are having the data sets. Now it's your turn to do what others did here. At least try. So they made three type of learnings. One is they made batch learning. This is first one. Okay, after that they try to do one more learning called as incremental learning and multi-class novelty detection. Yes, here now. So first one is batch learning is done, multi-class novelty detection is done. Okay, so these are the models which they used for comparative purpose. So IAKDA, IDA, KNDA, and LDA. These are the four new models. So what they are using for their comparative purpose, and then these are the these are the proposed models: FKDA-X, FKDA-CX, FKDA-C. Now you see the analysis here. So now first one is figure gives you this A, figure A gives you the error rates for novelty detection, and what they are claiming is that their algorithm has produced very less number of error rate. You can see, so this last three from green, this light pink and red, these three are these proposed algorithms. The first two are the existing KNDA, MINAS. So what they are telling, the error rates has reduced for these three than these two. These three error rates are reduced. Error rates are reduced. These are the three chunks. which are coming. And then the second one is they are giving for some other data set here. So that is for one data set, and this is for another data set here for AR detection on AR data set here. This is ORL data set. Okay. So of course here also the error rates for this new proposed model is very much reduced. Agreed. Of course, the algorithms are good here. They had produced good results, and here you can see the accuracy point of view. So how the accuracy? So here you can see for this FKDAX, the accuracy values are 98.66, 88.62, 77.50 for this range, and these are one of the best values what they have obtained, what they are telling here. Okay, then going little forward, so not only this one, they did learning on the novel class increments also. So this is what we can say here. This is the CPU time. Okay, so again here also you need to understand this diagrammatic representation, comparison of incremental learning. So previously what we have seen is simply FKDAX, FKDA, CX and C. Now these three are the incremental versions. See here, IFKDAC. Actually, this is also I. They missed here. It's a mistake. Okay, IFKDA, because you can see here, na. So here it's written C. IFKDAX. Okay, little things will happen like this. See, IFKDAC. It's IFKDAC and FKDA. Okay, so right. So in this charts you can see, understand. So here the last one, two, three, four algorithms are the proposal algorithms. One, two, three, four, and first three are the existing algorithms. So they are claiming that accuracy of this is better. Yeah, you can see it's of course better for their algorithm. So that's what the total paper is regarding here. And now coming for the beautiful conclusion, what they have presented that their proposal factorization free kernel discriminative analysis, FKDAX is the first proposal what they did here. After that they made two optimal versions of their proposals as FKDACX, which uses micro clusters. Okay, micro cluster centers, and FKDAC, which uses the centers of the clusters to find the novelty class detection. Okay, so that's their new proposals here. And now just to go for the future work what they are telling. So they said that they are going to give their future work as the applicability of these on the deep learning networks. So still now they have just did in the normal learning process, no? So now they want to make it with the deep. So in the novelty detection and classification for the feature learned by deep learning networks on AWA and CATEC 25 data sets respectively. They want to go for the novelty detection of the data sets for this for this particular data sets. So what are those two? AWA and CATEC. So they want to apply their novelty detection algorithm FKDAX, FKDACX, and FKDAC with incremental version on the deep learning network with on these data sets. And they are telling that then then we will use the transformation matrix to learn by these algorithms for the raw data as the input parameters of the deep learning neural networks to optimize the learning process. Then they are simply claiming that whatever the applications that the deep learning networks are targeting, now all those applications will be the target for their new proposals in the future, what they are claiming here. And of course these three new proposals what they did are a good versions of the proposals, and there is an acknowledgement of a grant also, right? And you can see the others here. There are 9 authors for this paper, so they are just having a good quality publication. So they are having the nine others here. You can check out their names in the starting of the paper, and here little bibliography is also there. Most of the persons are PhDs here, doctorates here, and of course they are having their master fellows also who are still pursuing. So this one, she's a master fellow, so master's degree in software engineering she's still currently pursuing here, and remaining other professors are just did their work in the work of the paper manuscript reading here, and experimental simulation is also done by a part of the team. And of course this is a teamwork, it's not like one person did all the things here. Of course, everybody shared their works here and they completed this excellent paper. And now you see here, so this paper is published in one of the reputed journal, I can say here. So that is this novelty detection in the IEEE transactions on pattern analysis. Okay, so this is one of the reputed journal. So for publishing in such a journal you should have a good depth paper, and of course this paper has that all the good qualities. And if you are going to take like this papers for your future extension of the work, or for your PhD thesis work, or for master thesis, then of course nobody is going to tell you that on what basis, on what are the base paper on which you are developing your work. Of course, you can claim that I have taken a paper from a reputed, a topmost journal from the computer science background, and we have did the work here. Okay, so right, that's all about today's video. So definitely, still you are watching at this point, then you are a most interested person, and of course you should be going for the subscription of our channel here. Okay, don't forget to subscribe, don't forget to like, and I am getting little less comments also. Don't feel anything, like you just give your comments here. You want more extension of some of the ideas, then I'm here for you. You can give your comments there. Or if you want more better understanding, of course I'm in this point, I'm not able to give a lengthy discussion of 1 hour or 2 hours. It will be possible, but now it is for the common and public audience here, so I am making it the video for 20 minutes. I'm trying it, but it's going just up to 30 sometimes. Okay, right, so who are more interested, no? Just give me a message, we will have little more discussion for a better and deep knowledge here. Okay, right, don't forget to once again subscribe, don't forget to like and share the videos. Thanks for watching. Right, best of luck for your research work.